Alrighty, so here we are with our graphing linear equations assignment, and so we're going to go through each of these. Remember that you can in fact graph any of these either using the table or by identifying slope and y-intercept. I'm just going to kind of work through each of these strategies every other time. So the first one here, definitely, especially with fraction as your slope here, the slope is always the thing next to the x, and it's so much easier with a slope as a fraction to use the idea of slope and y-intercept versus a table. So either way, of course, you can use a table, but in this one I will not be. And then in the next one, to make it different, I will use it. So the next thing that you need to know is that the y-intercept has to do with this digit that's right here. And again, we're intercepting on the y-axis. And so that means that the x value is always going to be 0 because you're not going anywhere left or right. You're just going up or down. So in that case, we have 0 and then -4 as your coordinate. So if 0, -4 is my coordinate to start, again, we're not starting at the origin when we do this technique. Instead, you're starting at the y-intercept, and then from there, you move the slope. This slope here says that we have 2, 3, and so that means 2 because it's positive up squares, and then 3 right from where you start. So in that case, up 2 from this dot is going to make us on this line here, and then 3 right is going to make it here. So I will put the next dot here. I also will finish this word and put a T there. Okay. Then from there we're going to go up 2 over 3 and get a dot that's there, and up 2 over 3 and get a dot that's there. Remember that you can in fact go down 2 and over 3 as well. So again, another way of looking at your slope is that it's -2, -3, because that's still positive. 2 negatives makes a positive. And so in that case, you would see that you're actually going down and left. So if we go down 2 and left 3, we continue the pattern and kind of complete our visual here. So connecting with as much of a straight line as you can. And then, of course, labeling 2/3 x minus 4 is our line that we have there. All right, so again, that was using the slope and y-intercept strategy. The next one here, we're going to use the graphing strategy, so I won't be using this piece here. Instead, I will just plug in each of these values into the equation. So giving myself a little bit of work room over here, if I plug in a 3 into this equation for x, I'm going to end up with 2 times -3 plus 5. So again, this came from the fact that it was 2x plus 5, but now x has become a -3. So if I evaluate this using order of operations, this is going to happen first. So 2 times -3 is -6, and then to that I'll add a 5. So that means that one of my first coordinates is -3, 1. Oh, sorry, -3, -1. Then if I do this same set of operations again, but instead in here I put a -2, evaluating that, you get -4 plus 5, and so your next coordinate is -2, 1. Continuing on, now we're going to, instead of a -2, put in a -1. 2 times -1 is -2, which we will add 5 to and get 3 as our next coordinate, -1, 3. And then, hopefully from there, you can actually see that there's a pattern. So if you add 2 to this y value each time, because it is linear, you can go ahead and note that this will be 5. After that, we'll have 7, and then 9, because we're just adding 2 each time. If you want to go ahead and check that that works out, especially because sometimes patterns can get away from us here, you can plug in a 3 and just double check that 6 plus 5 is 11, which is what we got over there. So that works out. Now we can go ahead and graph each of these. So if we plot the points, our first point here is -3, -1, so down 3 or over 3. Sorry, yeah, left 3 and down 1. The next one is left 2 and up 1. and then left 1 and up 3, and 0, 5, 1, 7, that's not really a dot, 2, 9, and then anytime that you get something on your table that is out of the graph, you do not, of course, need to like make another line and take all your time, whatever. We're not doing that. The idea is that you would just skip that one. And of course, if you can, you would go ahead and try to continue this pattern, even though the graph doesn't have it, over here. So I can see that I'm going to be going down 2 over 1 to get to the left there. And then you would connect with a nice straight line with arrows that go through the points and not necessarily stopping at the points. I have a lot of students that will just connect the dots and kind of stop at the dot, but of course this is a line and it goes on forever, so we want to have those arrows there at the end. Alright, and then of course if we label our equation, we have y equals 2x plus 5. Alright, so that is the using a table strategy. The next one here, I'm going to use the slope and the y-intercept. So if we look at what is next to the x, which is the slope, we have a 1. And of course, if we have a slope, we want it to be in a fraction. So what divided by 1 will still make 1, and that is a 1. So it's odd, but our slope is 1 over 1, meaning you're going to go up 1 and right 1. And when we move, we're going to move from the y-intercept. And the y-intercept, remember, x value is always 0. And then the y-intercept is this 3 value. So 0, 3, so over nothing up 3 is where our first point is. And then from there, we're going to go up 1 over 1. So kind of go to each of these corners. And of course, it does then continue going backwards as well. And that's because instead of positive 1 over positive 1, we could also have negative 1 over negative 1, which means that we would go down 1 and then left 1. So either way, we're going to make this diagonal here. And so now I connect each of those. And that is my equation of y equals x plus 3, my graph. All right, this is your next assignment problem. So in this next one, I'm going to use the table because I'm switching every other here. So I'm not going to use these pieces. Instead, I'm going to plug in a negative 3. So our original equation is negative 2x plus 7. But instead of that x, I'm going to have a negative 3. When I simplify, I'm going to simplify by multiplying first and then adding. So positive 6, and so 13 is our first digit. Next, I'm going to do the same process, but now I'm going to put a negative 2 in. And negative 2 results in a 4 from that first set, and an 11. Trying again with negative 1. Leads you with a positive 2 or a 9. Continuing on, we can see that the pattern shows that we are taking 13 and subtracting 2 and subtracting 2. So if I want to complete this, I can put a 7 and a 5 and 2 more and down 2 again. So going through graphing, I'm not going to be able to graph the first 2 points because they are too tall for the image that we have. So I will just start with this graph, this point here, which is negative 1, 9. From there, I'm going to go to 0, 7, and then 1, 5, 2, 3, 3, 1. And then continuing that pattern, you can see that we're going down 2 over 1 to get to our next spot. So if I'm going to go down 2 over 1, I'll also be at 4, negative 1, 5, negative 3, and etc. all the way down here. And so this is our line for y equals negative 2x plus 7. All right, and then our last assignment problem is number 5. And in number 5, we have a fraction as our slope, so that's always nice to have as the slope versus as a table, because you end up getting a lot of decimals if you have fraction slopes. So looking at our slope, if it's -1 over 4, that means that we will go down 1 and to the right 4 in order to complete our graph. The y-intercept, as always, has a 0 for the x and then a -3 in this problem. So we'll start at 0, -3, which is down here, and then from there we will use the slope of down 1 over 4. So this is going to be a very horizontal looking line. Other than down 1 over 4, you can also have up 1, left 4. Because again, one negative will make this fraction negative and keep this one negative. So we don't want to put 2 of them in there. So if that's the case, then we can go up 1 from our y-intercept and left 4 and get to our next point. And of course, you can also just see that by the pattern as well. So you don't have to be too clever about that. And then we will connect each of these. And we have our last equation of -1/4 x minus 3. So hopefully that makes some sense to you. And again, there are those 2 strategies. You can always graph no matter what kind of equation is with a table. And then, of course, that strategy of slopes and y-intercepts.